What? It's a bit warm here. Oh, hello there. Alright, what am I doing? Okay, yeah, there's something. I remember that I missed the last bit of this. I'll go to day 19. It's already day 19. Pretty good.
It's kind of it jogs. I don't actually remember. Let's see if there is. I felt like there was a way we could figure out to verify that it was right. Well, we can look at the H result at the very least. So if this MM result thing that comes back, if that returns time no error if successful.
Request a minimum resolution for periodic timers. Yeah, I don't know what
It's
this
not a perfect
is.
fix, but we can fix this. We can fix it with something called time begin period. Now, what time begin period is, it's a weird.
Minimum resolution for periodic timers. What is this? Yeah. Can I get the same in Zik? I think this is also by Casey, isn't it?
In the previous
Yeah,
video,
that's what I thought. Not sure how meaningful this is, but the results vary quite drastically if you run this multiple times. RTDSC. I do remember I have a to-do on this. This is how you write assembly in Zig. Not sure if this is what I'm looking for.
I don't even want to know how this ended up being the way to do this. You can sort of see how, but oh my lord. You would think there'd be something called set scheduler granularity, but no.
Scheduler granularity. I gotta know what this thing is. Over to cloud. What is scheduler? Granularity. Ah, okay. Okay, so setting precision, if I'm not wrong. Set time, no, it's thread. No precision of timing is guaranteed. I mean, at this point, I don't know if it's like necessary. Then again, don't want to add another to do. Maybe I'll add another to do. Thread dot sleep. Maybe I'll write it in a way that I'll understand. This method, what is called?
What actually happens is time begin period is like an old multimedia system call for setting when you would get callback timers and what resolution they had to be. And of course, the callback timers couldn't happen in the timer granularity unless the scheduler was waking up at that granularity. So it ends up setting the schedule granularity in Windows, and it sets it to whatever this period is here, right? So that period is in milliseconds, which means the schedule granularity we can set all the way down to 1 millisecond, which is fine because we're only going to sleep at a millisecond granularity anyway. I don't know if that makes sense, but hopefully it makes sense. I don't actually remember, to be honest with you, it's been a long time. I don't actually remember how you make this call. It escapes me at the moment, but we'll go ahead and put it in here. Excuse me. So basically you call time begin period, and you pass it the millisecond granularity that you want. Excuse me. So basically, desired scheduler millisecond, like that, is 1, just so people reading this code knows what's going on. Note, Casey, set the Windows scheduler granularity to 1 millisecond, so that our sleep can be more granular. So let's do that. So there we go. And now I just can't, the only thing I can't remember is whether you need to actually, well, you know what I think? Yeah, you know what I think? I think there is one other thing that we want to do. I'm just, it's the memory is kind of, it jogs. I don't actually remember, let's see, if there is, I thought like there was a way we could figure out to verify that was right. Well, we can look at the H result at the very least. So if this MM result thing that comes back, if that returns time no error if successful, I like timer no can do. That's interesting. Someone had a sense of humor there. So basically if that does this, then it's okay to sleep, or I should say sleep is granular is true. In fact, we could just do this. We could just record this like that. Bool 32, sleep is granular equals that. So there you can sort of see, I'm just basically recording whether this worked. So if it believed it could set it, then we'll set it. Now the reason that I wanted to record what it is because I don't want to introduce this sleep if the operating system isn't going to be able to do it. So basically I want to do, if sleep is granular, then allow the sleep, otherwise don't allow the sleep. Does that make sense? Now that was, like I said, a multimedia function. So in order to link with that, we have to link with the multimedia library, which is pretty trivial to do and exists on all Windows. So that's not a risk. It's not a linking risk. I believe it's winmm.lib. Yeah, it is, of course. Remember, you can always determine that by going down here, but sometimes I like to see if I still remember. So, all right, now we have basically gotten that working. Our sleep should be more granular, but we still have no idea whether this is working right or not. Like, we've got no idea, and so we can't really make any conclusions yet, but we're out of time for the day.
What was I? Oh yeah. Okay. Gonna set that aside for now. Move ahead because I think audio synchronization is what I wanna.
Okay, welcome everyone. We are here. We are narrowing in on the 20th day. We're on day 19 of Handmade Hero, the show where we code an entire professional quality game from scratch using...
Ooh, I can see it's gonna debug. What do you think?
Nothing, no libraries, no engine, no nothing.
Well, I think I've used the standard library. I think I'm past using no library though. I mean, it's fine.
So that we can learn about everything that goes into a modern game. And basically the goal with this series is to show how everything works so that everyone who works on games will basically have a richer understanding of what's involved, and they will always have the ability not only to understand what their engines or their libraries or whatever is doing, but also to drop down there and fix problems, create their own new libraries, improve upon the tech that we have, and basically just give everyone the opportunity to understand the full pipeline and really be fully effective and never let there be limitations in their game development because of the fact that something is opaque to them and they don't have the knowledge necessary to kind of go in there and take charge of something themselves. I think it's been going great so far. I've been overwhelmed by the response from everyone. I think it's amazing and awesome, and I can't thank everyone enough for making this series so exciting. And so, yeah, with that, I will simply say let's get to what we're doing today, which is finishing up the Win32 platform layer. Today and tomorrow, I think, will be the last days, probably.
Well, I'd like to say thank you, Casey, for making this. It's pretty awesome.
That we'll be working on our Win32 platform layer.
And it's also helped me, like, what's it called? Get over the stigma, or like the fear. of working with lower level libraries. So yeah, so far I love it.
And today what we want to do is kind of work on our audio sync. I explained yesterday the sort of stuff that we need to do for it, and today we're going to be trying to actually get some of that stuff implemented and hopefully test it a little bit too, just so we can have some confidence that our frame loop is actually working properly before we sort of push onwards. Now, if you have pre-ordered the game on handmadehero.org, you should have gotten a link in your email to a place where you can download the source code. If you download that zip file that's up there, the source what we know is we are going to open a sound buffer, and we talked about sound buffers extensively early when we first implemented this feature. If you haven't watched those videos, I highly recommend you do. It'll kind of clarify to you what's going on with direct sound when we output the sound. But basically, what we are doing is we're outputting 48,000 samples every second to the sound card. And what a sample is a sample is one value for the left and one value for the right channel that basically say the amplitude at that one point in time. So basically what we're doing is
why is bytes per sample? Size of Win16 times 2. Do I initialize my audio? For channels, I guess I've already multiplied it here. Okay, so I'm guessing it's for channels. Samples per second multiplied by bytes per sample. It's the buffer size. Okay. Yeah, sample rate times number of channels and size of it in 16.
we're taking 48,000 amplitude points, and that is what's reconstructing the wave that's coming out of the speakers to first approximation. There's a lot of stuff that happens to it on its way out from the computer to the speakers, but to first approximation, that's basically what we're doing is we're trying to find that wave. Now, for a number of reasons I discussed way back when we first started doing this, it's not strictly possible to actually perfectly synchronize those waves with what shows up on the screen. And the reason for that is there can be delay that happens at all different stages, all the way out to stuff that's completely external to the computer. For example, if you have a HDMI cable, and even if we ensure that our audio and video are synced perfectly going out of the HDMI cable, that may go into a user's receiver where...
And I forgot what latency sample counts.
Gets split off.
I might have missed a few things.
Off into like one thing that goes out to speakers and one thing that goes out to the TV for the video, and those might be delayed separately due to circuitry and all sorts of other stuff. So to a large extent, perfect sync is not achievable on modern hardware. I wish it was, it's not. So what we're trying to do is not really achieve perfect sync, but what we are trying to do is make sure that we don't do such a poor job in our own outputting that basically we create a really bad sync problem even before the hardware gets like. We don't want to exacerbate an already bad situation by ourselves making a very laggy, lax output of audio and video. So what we're trying to do is ensure that as we output those samples, we try to have some measure of control over when they are going out. And we hope that they are leaving, they're basically getting pushed out of the computer. We kind of want them to get pushed out across the time period that corresponds to the frame that we wanted them to be heard with. So if we want a certain set of sounds to be heard across the length of a particular frame that we're outputting, we're trying to line it up so that they come out of the computer at that time. So we have unfortunately, we have very limited ability to do this on some platforms. On some platforms we have more, but we have very limited ability on some platforms. On Windows Direct Sound in particular, which is what we're using, basically what we have to do is we have to use this thing called get current position. And what get current position does is it allows us to retrieve from Direct Sound where Direct Sound believes the audio to be playing at the time. So it's where it's sort of telling us, this is where I think the audio is playing out the hardware at the moment. And it returns us something called the play cursor, which says what that is. So what I'd like to do sort of at the beginning here is just, I'm going to go ahead and make a debug diagram just using Win32 as we debug the Win32 platform layer here. I'm going to make a little debug diagram that draws the play cursor for us, just so we can sort of get a feel for where it actually is in our ruling sound buffer, if that makes sense. So what I want to do here is basically right at the end, we're going to do a thing here, this Win32 display buffer in window sort of thing. Basically what I'd like to do is start to think about exactly, excuse me, I'd like to sort of try to get, if you will, exactly where Windows says that play cursor is at the time when we're about to do our blit, right? So it's a little sloppy because our blit isn't instantaneous, but you know, we're going to try here. So basically what I'm going to do is I'm just going to do a little thing here and say, you know, no, this is debug code. So we can probably do a thing here where we're doing, I can't remember what our definition was. We had a definition for it here, code build.bat. We were going to use Handmade internal. So with Handmade internal, we could go ahead here and do this sort of check. So if this is an internal build, I'm going to go ahead and ask that that buffer for the play cursor, basically right here, and I'm going to wrap this just because this is an internal thing. I'm going to wrap it in some braces here, just so these two things don't escape. So it's just a little local thing that I'm going to do here, right, like this. So what I'm going to do is I'm going to ask it for where that play cursor is, and then I'm going to store that value so that on the next time around, when I draw the frame, I'm going to actually draw where we thought the play cursor was relative to our buffer at that time, right? So basically what I'm going to do here is I'm going to say, all right, I'm going to get that play cursor, and then I'm going to have a thing that I'll put kind of up here, just a variable. It's not a global variable, but it's going to sort of be effectively global because it's in the scope here. I'm basically going to say, all right, you know, once we actually get this thing going and we're going to start this, I'm going to do a thing called debug last play cursor, and I'm just going to remember basically where that debug last play cursor was all the time. So we're basically going to say we get the play cursor back, I'm going to set it like that, and we don't actually care if this call fails or anything like that. It's just debug code, so we don't have to check anything, but we're just going to take a look at where it was, and you know, in the at the time when we're about to do our page flip, basically. And you know what? We could do that even a little bit. We could do that even a little bit more sort of accurately, I think, by doing it after the page flip is done. So we'll do it here, right? So that basically says, okay, after we've submitted all our stuff to GDI, and we don't really know when GDI is going to display it yet. Later on, we'll sort of have more of a ability to do that. But I wanted to show you how to do this code. You know, just get this code in there first, and then later when we have a lower latency page flip where we can actually think about it maybe a little bit more, we can sort of get this tighter. But basically, I just want some semblance of a debug display, something that tells us roughly where the audio was at the time when we tried to do our page flip. But I just want to impress upon you that, again, we're not getting 100% accurate stuff out here. Windows is taking that bitmap that we gave it, and it's going to possibly delay until the vertical retrace to flip it. So we're just trying to get like within a 60th of a second or something of the correct answer, just so we can see if we're totally off base when we start to do our audio sync. So we're trying to get just something. So there we go. I've got that debug last play cursor. And then what I'm going to do is right here, when we do this Win32 display buffer and window thing, right before that happens, basically what I'm going to do is I'm going to insert another call here that's going to call up in the case where we're in the internal mode. I'm going to call a Win32 debug sync display or something like this, right? And that's basically going to pass that global back buffer, and it's going to pass whatever the last play cursor was, right? That debug last play cursor. So that's all I'm going to do, and then I'm going to draw that on the screen, and I would like to also pass it the sound buffer if possible, which let's see, just so it can understand sort of the length of the sound buffer, how big it is, that sort of thing. So we have a thing here, Win32 sound output, so I'm going to go ahead and pass that as well. So that's going to take this thing here, right? So there we go, sound output. And that's the address there. So I'm going to go up to the code up here and just drop that in. Here is our internal debug function here that's going to draw some stuff, hopefully. We hope that it's going to draw some stuff. And that's going to take this Win32 sound output buffer, first of all, and it's going to also take this off-screen buffer. And then it also has this D word here that is whatever the last play cursor was. So that's where we thought the play cursor was. And then all I'm going to do, nothing particularly interesting, all I'm going to do is I'm going to pretend that the width of the off-screen buffer, right, maps to our entire sound buffer, right? And you know what I'd also like to pass, if possible, is I'd like to pass our target hertz as well. Where is that? That's here, game update hertz. There we go. Well, seconds per frame is probably better, so let's pass that. So I'm also going to take the seconds per frame there. That's all I really wanted. So what I'm going to do is I'm going to basically start by just drawing a really simple, excuse me, a couple things in here. I'm just going to draw basically maybe some little rectangles that will sort of demarcate where our desired frame boundaries are, if that makes any sense, sorry, rather where our page flips are. And come to think of it, I'm probably going to want to draw more of them than just the last one as well. So in some sense, I think I may want to basically do something where we actually have more of them kind of here than just one. So what I think I might do is go ahead and say, all right, the debug last play cursor, actually, we keep some number of them, right? We keep some relatively large number of play cursors. And let's say that we keep, like, say, the last, let's say if we're doing it at 30 frames a second, let's say we keep the last 30, right? So basically our game update hertz, we'll keep that many of them, if that makes sense. Okay, so we're basically going to track that many. And the way that I'm going to do that is just say that there's an index into that array, right? And that index I'm just going to update over time so that we write in the last play cursor based on that piece of information. So here we go. Let's go ahead and do that. I'm going to do that here. And we'll expand this, I think, in a second here. I feel like probably. But for now, right? So we'll basically just do that. We'll write in what the play cursor was into the array. And then if we happen to get to the point where this is higher than the array count, we're just going to wrap. So it's just going to be, we're basically just going to be a circular buffer where we just keep writing into it, and when we get to the very end, we'll go back to the beginning, if that makes sense. So that's it. Nothing particularly fancy there. That's all we're doing. Hopefully that makes some sense, right? Excuse me. Why didn't that one initialize for us? Is that better? Expected constant expression. Oh, right. Sorry. This game update hertz here has to actually be something that can be a constant expression, so we can do that temporarily. There we go. All right. And let's see. What else we got? Win3db sync display, that needs to take our other parameter there, the seconds. What was it actually called? Target seconds per frame. So I'm going to pass that as well. And there we go. Let's see. Off-screen buffer cannot per 1 to address of. What did I do? Did I forget the pointer? I did. Yes, there we go. These are supposed to be pointers, not ampersands. Okay. So now we just have to do a thing where we're actually going to pass this thing and how big it is. So we just need to pass basically our last play cursor array, if that makes sense. So we're going to pass the whole thing. Let's see there. And then we will just modify this to take that as a pointer. Last play cursor count. So there we go. All right. So that's just going to give us basically what we need to draw. And now what I need to do is I need to step through that. I need to do play cursor index. I need to step through that array, and I need to draw each one of those into the window basically as a little rectangle or something, so that we can actually see what is going on, right? Excuse me. So basically we've got this bitmap here. We know that it is width wide. Right? So we know that this is how big it is. And then we know that we've got essentially our sound buffer is going to have a thing that has this secondary buffer size divided by bytes per sample. That's how many sample indexes there are in the entire buffer, right? And this guy, well, I guess we don't actually care because these play cursors are not actually in samples, they're in bytes. So basically we just need to use this, right? The secondary buffer size is the width.
Going way too fast. I can't keep up. I get what he's trying to do, though.
Width we want to draw. We wish we had a buffer that was that big to draw into, because that's the sort of range that we're talking about. But we actually only have something that's this big, which means that we essentially have to sort of map that secondary buffer size range into the width that we have. Right, and so basically what we're going to end up with is we're going to end up with a division here, right? We're going to have a coefficient, which is basically going to say for something that is actually mapped in the buffer size, and we want it to now be mapped in the width, we're going to basically just make the ratio that maps those out. And again, if you remember, I talked about dimensional analysis before. This is exactly what I'm doing here. I'm basically going to multiply this coefficient by the input byte count that we get from the play cursor, right? Those play cursors. The play cursors are in sample buffer bytes, and this is sample buffer bytes. Whereas I want them in pixels, and this is in pixels. So I'm multiplying by pixels, dividing by sample buffer bytes. The sample buffer bytes units cancel, and I just get back basically the units that I wanted, which is the pixels, so I can draw it. So that's all that's going on here. We talked about how this worked previous streams when we were talking about dimensional analysis and ratios, but that's exactly what all that's doing, right? So what I want to do is I want to draw this. So basically I can just say whatever the value of last play cursor is in this particular circumstance, right? Basically all I'm going to do is do a floating point multiply there to get out basically what the x value is. And that is the x value for where that page flip basically occurred. Now what I want to do is I don't want it to go all the way to the end of the buffer. So what I might do is also say, okay, there's a little bit of pad here. Let's say there's pad x, right? So maybe we'll start 16 pixels from the left and 16 pixels from the right, just so we can actually see it. So there's a little bit of a margin there. So what I'm going to do is say that I want it to map to actually a range that's not quite that, right? I want to subtract that out of the range. And then when I actually draw this x value, I actually want it to be looking more like that, right? Hopefully that makes some sense. And really, I guess I'm going to have to make this be an integer because these are plotted as integers. So we'll do the multiplication first, but then we're going to have to actually convert it back. The reason I'm doing the multiplication here is because I don't want to have to do the multiplication in something hairier. I want to be able to store ratios and stuff like that. So I'm doing the multiplication in floats, and then I'm casting back to integers when we need to draw. So what I want to do here is I want to do a little debug draw line, basically, to draw, in fact, I don't even need to draw a line. I can just draw a vertical, like a hash, basically, which is extremely simple to draw, and I don't have to talk about how to do something like, a crazy, like, Bressenham line drawing or something like this. So what I'm going to do is I'm just going to pass that in. I'm going to say the global back buffer, and then I'm just going to say, basically what I want that hash mark, where I want the top and bottom of it to be. So basically, I'm going to say, you know, I don't know, global back buffer. You know, I guess I'll just do top and bottom, something like that. And then we'll just say what those are. Top is going to be equal to something. Bottom is going to be equal to something. They will basically be the global back buffer height. You know, I don't know, minus pad y, let's say. And we'll make that be 64 or something. Well, we just make it 16, even boards all the way around. This is going to be a very funny looking diagram because it's going to be so tall. But hey, what are you going to do? We can adjust that later. And then I'm going to say that it's just going to be pad y here. Oops, that's broken. Pad y for the top and minus pad y for the bottom. So then I'm just going to have to write this function, right, which is a thing that draws a vertical line, which is extremely simple to do. Although, you know, whenever you're writing stuff at a low level like this, it's always error prone. It's why you typically make a graphics library. We don't quite have time to do that yet. That's what we will be doing sort of next week and going forwards in our game, so that we'll just be able to call things like draw a line and they'll just work. But for the time being, it's pretty simple for us to just sort of hack something together that will serve for our debugging purposes just fine. So what I'm going to do here is I'm just going to step the y. This is going to be the world's slowest and worst way of doing this, but I'm basically step the line from the top to the bottom, basically, and then I will draw each pixel. So really all I need to do here is get a pointer to the memory that we want, which is basically going to be a cast of this, let's see here, a cast of the memory for the...
I do think the top and bottom. I think he messed up the order. I'm not sure. Is that it? Yeah, here. Top is height minus pad y. Yeah. And bottom should be pad y. Okay, I think it's the opposite. But let's see.
Cast of this, let's see here, a cast of the memory for the bitmap, which we've allocated, and we've drawn to this before, so you guys are all familiar with what I'm doing here. But basically, this is the pixel that we're looking at. It's going to be that back buffer memory times, we're basically going to move over however many bits per pixel it is, right? Which we already know exactly how many it is. It's basically 4 bits per pixel. You know what? I don't know why we didn't. Oh, because it's in info. That's why. I believe the bitmap info is the thing that stores the bits per pixel, right? But anyway, I feel like we should have had bits per pixel out here, and I feel like we didn't. I feel like that got removed or something. I'm just going to say bytes per pixel here. I guess because we already know what it is as well, so it could pretty much be a pound to find. But anyway, I'm going to move over the x bytes per pixel, and that puts me at the correct place. But I also have to put over go down y times the pitch, right? Because I have to go that far down from the top of the buffer. So we just need to know what this actually is. So I'm gonna actually say let's go ahead and get that back in there. I don't know why that went away. I'm sure we could go back on the stream historically and find out why it went away. Maybe someone recommended it. Maybe I was stupid. One or the other. Both of them are very possible. But then when we get to this particular pixel here, we're going to write, excuse me, we're going to write into it as a uint32. So we can actually, I guess I can just cast uint32 there.
I don't remember what that was for. Remember bytes per pixel. What was pitch? Was it the offset? Not sure.
So we'll basically do it like this, uint32 star pixel. We'll write to it, and then we will add to it the pitch again, right? So there we go. That. And when we write to the pixel, I don't know what we're going to write in here. We didn't actually specify a color. I suppose we should allow the person passing it in to specify a color. So there we go. And then we'll just have the draw vertical guy specify a color, and the color for now can just be that color. And now we just got to do that bytes per pixel when fix the errors. I don't actually know. Again, I don't know why we got rid of bytes per pixel. It feels kind of weird that we did. But let's put it back in there, bytes per pixel. And then when we are setting up that pitch, I would like to set up that bytes per pixel. So what I'd like to do here is just say, all right, bytes per pixel is here. Let's just go ahead and get that in there so that we already know, because we've already got it defined here, and let's just do that. Oops. There we go. Just to make sure everyone's using it, just seems like a better idea. All right, so Y, oh, right, it's top, not Y. It is top, there we go. And secondary buffer size is something that is passed in the sound output, so that actually needs to be referenced here. All right, so we just typed in a crap ton of code. There's probably some problems in there, but hopefully you understand what I'm doing. Really all I'm doing is I'm stepping through a bunch of cursor positions that we saved in a rolling buffer, and I'm trying to draw them out. Basically, when I draw them out, I am going to have a, excuse me, I'm going to have a vertical line. So all I did there was I just stepped my pixel pointer to the top. I stepped it over by the X amount for each byte per pixel, and then I stepped it down by...
I'm just waiting to see the output so that I can do it myself.
By the pitch, however many the top was. Then I just did as many rows as there were between top and bottom, and each time I wrote the color out to the pixel I'm at and advanced by the pitch to move down to the next row. Really pretty basic, nothing interesting going on there at all. Like I said, just kind of finicky because we don't have a graphics library at this point because we haven't gotten to that point yet. It's always hard when you start from scratch. You kind of got to juggle as you kind of go upwards, but eventually, and it's not that long into it, you kind of get to a point where you've got sort of a lot of leverage underneath you, and then these sorts of things aren't an issue anymore because you've got your line draw, you've got your rectangle, and you're totally good to go. That's exactly what I thought would happen. You always crash the first time because you forget something. So let's take a look here at what we're doing. So what are we doing wrong? Our back buffer memory times the bytes per pixel. We did cast to a UNT, so that's good. Our tap value of 16 times the pitch, and I don't actually know what the pitch is. The pitch may be negative in this particular case. I'd like to take a look at that just to see. Global back buffer. There we go. Take a look at that. The pitch is not, so we're moving forwards each time by that pitch. Excuse me. So, and then we've got a 704. What is our Y at this point? It's at 123. So we started off okay, and then when we got to 123, we crashed, which suggests that we are advancing too far each time through, or something similar to this. That's a little suspicious, and I'm not sure why that would be the case. So let's take a good look here and see what's actually going on. So the global back buffer's memory pointer is here, right? That's what that is. And our pixel pointer, so I'm just going to take a look at what our pixel pointer is subtracted from that. Oh, sorry. Let's take this global back buffer. I want to see what the memory size is, if that, assuming that that was a char star. So we'll cast that and see. Oops, unsigned char star, sorry. Okay, unsigned char star. So that is the difference there. So the pixel pointer, that's not good at all. That is not good at all. What did I do? I did something totally crazy there. This is one of those things where, hey, it's just like I probably wasn't paying attention, and people on the stream probably already have it, but I'm not going to look over there again because I would like to figure out, I would like to go through the steps that I would normally go through to figure it out. Like I've said many times on the stream, I want to kind of show how to debug stuff. And so when I have a bug, I'd rather just kind of go through it slowly on my own, even though people who have kind of been watching and not talking the whole time probably already can see what it is if they're professionals. Okay, so basically I know that I was going to draw in this code, right? So let me step in here and just start going through it. Basically, I've got the global back buffer memory pointer. I know what that is. And now I also know what my pixel pointer is. You can basically see it here. And it looks to me, oh, I'm just doing the subtraction backwards. That's it. So that wasn't actually wrong. There we go. So if I do the subtraction here now again, then I can actually see. This is how far in I stepped just from the beginning. Right, so just that first step when I did my pixel offset, right, when I tried to start from the beginning of the bitmap memory and go a little bit further into it. Basically, all I was doing was I was going to add this much, which should be, let's double check the math here. I was going to add this much to get us to the right row, right, which is 8190, and I was going to add this much here for the x, which should be the remainder, right? Oops. Inserted an errant token there, right? And that looks right, like it did the math right. Now 5120 per row, does that sound about right? 1280 times 4, that is what that is. And if we were going to do 16 of those, right, that is what we expect. So that looks like the right number of bytes to step for the start, in my opinion. That looks correct to me. That is what I would have expected to have happen, certainly. So it looks like our computation there is correct. Then we come in here for our y. Our y is going to start at 16. It's going to step to 704. And basically what we're saying here is we're going to write to this pixel location. I want to, you know what, I shouldn't have deleted that. I want to keep this here for now so I can see what my offset is. Let's see here, global offset memory, so that I can keep subtracting the two of those and just see what their value is. So there we go, 8194. And then I come through here and do my addition, and I step a row. So that is what I would expect to see happen. So I'm going to set a breakpoint here and just make sure that this happens. Okay, that's interesting. So it actually succeeded the first time through. So it looks like it may be a computation of our x that is wrong. Perhaps our x is actually off. This computation here, when I kind of hastily sketched in this thing here, it looks like that might actually be wrong, because it looks like as long as the x is low, which it is at this point in time, the thing seems to work, which would suggest that perhaps my x computation was incorrect. So let's take a look when I actually get the crash now. I'm just going to step directly to the crash. What the actual x value is to see if that's, yeah, okay. What do you think? That is not a very good x value. Okay. I'm kind of glad. This is exactly what I hope to show on the stream. I know it seems weird to be happy about showing you not being a very good programmer, but this is exactly what I want to show on the stream, is this sort of thing. Because this sort of thing happens to me all the time. I am not a great programmer at just writing exact stuff right the first.
Excuse me. What I think is also this. Shouldn't this be the other way around?
Time.
No, sure.
I always make mistakes, and then I just have to debug them, and it's really not a big deal. It's one of the reasons that you make libraries as well, is to kind of debug them once and then have them, and I'm a big advocate of that because I do make a lot of careless mistakes. But yeah, so I just want to show you. So you saw how I found that, right? Like that was pretty clear how I went about debugging that. I just looked at what the memory was doing. I just looked at the pointers, and I was like, oh, okay. I can see that it appears to be tracking the y properly. So, and on an x that's reasonable, it seemed to work reasonably. So I'm like, I guess the only other parameter there is that the x must be out of bounds, and then that kind of clued me into bother looking at that. Now, if I looked at the x first originally, I would have seen that right away, but I didn't do that. So maybe that's also a good thing to remember. Always check all your parameters once just to see. But yeah, so that's pretty simple. We found the bug there. So it's just a bug in the x computation, which makes sense because I just kind of slammed that in there and didn't even think about it. That was not particularly bright, certainly. So let's think about this a second. What were we actually doing? So basically what I wanted to do with my computation here, and we'll go ahead and build that and then step in. What I was trying to do with this computation here was just map from the bytes that the play cursor had basically out to the pixel width. And so I was hoping that this would be a relatively straightforward thing, but it looks like I made a mistake when I was doing that. So what I'd like to do here is I want to, just so we can debug this and look at it a little clearer, what I'd like to do is break the computation into two steps. So here is going to be the two steps. First, I'm going to compute the x in real 32, right? And then I'm going to cast it and add the pad. So that way we can see the result of multiplying by our coefficient, and hopefully that will let it inspect it a little bit easier. Furthermore, I'm going to get this out into a local variable, and this is basically just me setting myself up for debugging success. I'm basically just trying to get these values out there so that you can see exactly what is going on in the actual debugger, right? So I just want to make sure I compiled that there. There we go. In here we can see what we get now in the watch window, and I can kind of very easily make sure that the various stuff that happens is reasonable. So let's take a look there at that's a totally reasonable value, and so is the x that results from it. Our coefficient also seems reasonable. So let's see what happens when we sort of go through these here. Does it seem to do anything particularly odd? Okay, that is really bizarre. That looks like a totally, yeah. So that looks like a totally uninitialized value of some kind, which makes me think that our clearing of this buffer did not work properly. That is what I am thinking, so I'm going to check that. But what I want to do as well is also drop an assertion in here, because the other thing that we kind of know is supposed to be true is that this play cursor is always supposed to be smaller than the secondary buffer size. That's just what we were expecting to be true, right? You're never supposed to be able to get, what is this, signed, unsigned mismatch. Secondary buffer size, I guess, is an int. So that's actually supposed to be a D word, I assume, but I'm not sure if we want to do it that way or not. We can do it that way for now. All right, so I'm assuming that assert will now just fire, and that assert will basically tell us that, hey, you're getting values that are totally out of range for what you were supposed to be allowing in this particular function. And I just wanted to put that assertion in there so that it's there and we'll catch those bugs in the future. Probably should have put one in there to begin with, but was not thinking. All right, so what that suggests to me is perhaps that this is uninitialized properly. Our buffer that I said was going to handle like sort of the circular buffer there. So that was this right here. And I want to, well, that's the problem. It looks like when I was hastily typing that in, when I modified it to be game update hertz, I accidentally deleted the thing I had so carefully included. You'll notice last night in John's language demonstration, he did the initialize by default unless you ask for it not to be thing. I would love that feature so much, because most of the time I want things cleared to 0. And stuff like that where you accidentally delete it is just, it makes you prone to errors that you shouldn't have. So there we go. All right, so we're totally set now for drawing. That's obviously drawing our stuff the way we wanted it to draw. Unfortunately, we also have the problem of basically, it looks like there's a little bit more than, 30 of them is more than actually fits. So I'm gonna maybe do a little less than that. I'll do half that just so it stays on the page. So there we go. Yeah, that looks about right.
Interesting. I was not expecting that. I thought they'd just be lines. This actually makes a lot more sense.
So basically what we can see already from this is we do have problems with our timing already. You can kind of see, just from what I'm looking at here, you can see they're not equally spaced. That actually reminds me of something I was thinking about last night.
Okay. I think now I can... How am I gonna do this? Game update and render. Guess then I could do this here. Debug sound. Take buffer. And sound buffer. Returns nothing. Okay. One of the things I did avoid, or like maybe not avoid, forgot. Input, off-screen buffer, price per pixel, and I think pitch. Yeah, maybe later. The width, height, memory. Logo. It would be 0 anyways, but U8 is not right. AI32. They can go left or right. Okay, and to fill the sum buffer. I think this one of the differences that was yeah, we only have there's no play cursor because we're using simple API from Pulse Audio, so we just write audio. Now the question was, what did that line represent? Can't remember. Was it? Not exactly sure. That XY. What's the relationship between line and the sound itself? Probably this. Use that. Yeah. Get rid of that. It's been. I don't remember the last time when I did. Okay, pixel index. Right, that's fine. Maybe plus. Oh, okay, I only need a single pad. far. Thirty-two bits. So that's FF, FF, and FF. Right now, this will fill the entire screen. Just not what I want. See what that big build from. Yep, just fills the entire screen. It's a start. Now I need to translate sound into pixels. The coefficient. What is sound? Let me see if I can write this down. Oh, but you can't see it. Represent audio as a line. I guess that's the question. Let me have a look at the sound buffer. Actually, now that I think of it, I shouldn't have been all white. There should have been a gap. Padding's missing. Interesting. Pixel index is no. Okay, that that drew a line. But not what I wanted it to. Padding's missing. I think this should be pad minus. Y times buffer the window width minus pad. But when y is 0, that's even more weird. Sorry, plus, that should be minus. I think this is not necessary. It's not what I wanted at all. Is that a single line? Yeah. I just want to see what this looks like. Okay, just moving to the right. Times 4. Yeah, okay, so that's seems correct. It's just the Y. Yep, I figured. Integer overflow. So index is usize. That's not right. Okay, so that prints a line. Now I need to print it when. What that stumps me is, how do you convert an audio signal to a pixel? Let me just go back, see what case it did.
Just using Win32 as we debug the Win32 platform layer here, I'm going to make a little debug diagram that draws the play cursor for us, just so we can call here that's going to call up in the case where now what I need to do is I need to step through that. I need to do play cursor index. I need to step through that array, and I need to draw each one of those into the window basically as a little rectangle or something, so that we can actually see.
Interesting. We don't have a play cursor. So we can't use the same method.
What is going on, right? Excuse me. So basically, we've got this bitmap here. We know that it is width wide, right? So we know that this is how big it is, and then we know that we've got essentially our sound buffer is going to have a thing that has this secondary buffer size divided by bytes per sample. That's how many sample indexes there are in the.
Okay. Yeah. Buffer size, bytes per sample. Yep. Okay.
Entire buffer, right? And this guy, well, I guess we don't actually care because these play cursors are not actually in samples, they're in bytes. So basically we just need to use this, right? The secondary buffer size is the width we want to draw. We wish we had a buffer that was that big to draw into, because that's the sort of range that we're talking about. But we actually only have something that's this big, which means that we essentially have to sort of map that secondary buffer size range into the width that we have. Right, and so basically what we're going to end up with is we're going to end up with a division here, right? We're going to have a coefficient.
Right, okay, I see. I think I get it. Where's my sum buffer? Buffer size, sample rate times channels. Is that correct? Oh yeah, because this is an I16. And I guess here, fill some buffer. Should be bytes. Not here, sorry. Right. Audio. Upper size times size of I16. But I think we can just use coefficient would be, which was bigger, sound buffer. Sound buffer dot headline. This should be, and how much width do we have? Buffer the window width. Sorry, divided by. Should be the other way around, I think. Window width is pixels. Buffer length is it's got to be a number less than 1. Is that correct? Secondary buffer size. I'm quite confused. Hey, return of run of return rectum of justice. That's a funny name. Yeah, they're mostly just archives of the stream, really. No, I can't increase the pitch by 1. That doesn't make sense. Pitch. I can just do pad. Yeah, I'm not sure. Let me write this down. Each line represents some buffer. Type some buffer. Is that correct? Gotta go back through it again.
Which is basically going to say for something that is actually mapped in the buffer size, and we want it to now be mapped in the width, we're going to basically just make the ratio that maps those out. And again, if you remember, I talked about dimensional analysis before. This is exactly what I'm doing here. I'm basically going to multiply this coefficient by the input byte count that we get from the play cursor, right? Those play cursors. The play cursors are in sample buffer bytes. And this is sample buffer bytes. Whereas I want them in pixels, and this is in pixels. So I'm multiplying by pixels, dividing by sample buffer bytes. The sample buffer bytes units cancel, and I just get back basically the units that I wanted, which is the pixels, so I can draw it. So that's all that's going on here. We talked about how this worked previous streams when we were talking about dimensional analysis and ratios, but that's exactly what all that's doing, right? So what I want to do is I want to draw this. So basically I can just say whatever the value of last play cursor is in this particular circumstance, right? Basically all I'm going to do is do a floating point multiply there to get out basically what the x value is. And that is the x value for where that page flip basically.
I don't have a play cursor, so damn, yeah. How are we gonna draw this out? This is not going to work. Hey, thank you, Rectum of Justice. You have a funny name. How can I represent this sound buffer into You know what would be cool? Because I'm playing sine wave. Can I print sine wave onto window? I could just plot it on the screen. Let's try that. That seems simpler. The width here for leave the pad as is. See, start from 0. Then you go to the right. Here. I think I could get rid of this totally. Move this out. Delete that. And then what are we doing? What are we doing? Yeah, go through some dot buffer. There'll be some index. Put that in there. Okay, now I understand. That's why I was getting confused. Because I'm trying to print vertically, but this loop runs like horizontally. Yeah, not confusing at all. This is not gonna work. Just gonna delete this, then start again. Maybe not all of it. Enter at height. Then I go Window width will be X. It should all be, it should be widescreen. Maybe, can I add a padding plus pad? Use that later. No, that's not what I expected. Hey, but actually that's not too bad. At least there is a padding. Why does it not print the rest of it? For the window. Print a single vertical line. It should be fully white. Okay, that's correct. It's also fully white. Can't do minus because that'll lead to, I think, integer overflow. Yeah. A ravish success. What I want to try is if I can just print padded white box in the middle. Where do I add padding. Okay, so at least it's padding on the top now. I need to do the same for the bottom. Index plus X. Okay, I see what I'm doing wrong. Be Y. Be minus 2 times pad. Okay, and then you shouldn't go all the way to the end. Minus 2 times pad. Hang on. To buffer dot window minus 2 times pad. I go here. It's width, and this should be okay, so there should be a padding now. Motherfucker. How is that possible? Pixel index is 0. That's not it either. What am I missing? No. Come on. Drop that wall link? What do you mean? Wall? Oh, you mean the wallpaper? Screen frozen. Oops, sorry. Oh, there we go. Hey, Ante. Yup. Yup. Oh, jeez, I'm losing my mind. What am I doing wrong? Should be padded X and Y. Taken 2 from the width and 2 times pad from the height. Oh, okay, I see. This should be pad. Is that correct? Okay. It's better, but it's not great. Why is it got all those gaps in there? It's just pad. Why does it look different every time? No, fill some buffer. I'll leave it as this. Whoa. I forgot to save it. Why does it not pad the X? Ah, I think I know why. Yeah. Pixel index plus X. The height is wrong. B minus pad. Okay, there we go. That's the start. It's not the same though. It's more padding at the bottom. Should be 2 times pad. Why? Oh, jeez, why did I stop it? Can't expand it. It's gonna crash the program. Oh, doesn't. Okay, it does. Actually, I could expand it a little bit to see why. I mean, if you're trying to guess what I'm trying to do, is I don't know if you can hear it, the audio. There's a small clicking sound. Trying to visualize the audio so that I can figure out why. This should be super. No, it should be the width. I mean, it'd be a nice time for the debugger to work. Only thing I can think of is does the window height include this taskbar? Possibly, I'm not sure. Okay, let's ignore that for now and try to understand why there's no padding added in the X direction. There's these weird gaps. I think my loop is the wrong way. It should be width. Should be height. Okay, that's worse. What? Oh, why? How is memory aligned? Make it 600 by 600. See what that looks like. Looks weird. Let me see if I can get the debugger to work. Folder. Handmade. Yeah, actually I don't need that. Where's forgot how you could add in here breakpoints. Yep. And that's it. Don't need that. Yep, that's it. Oh, yeah, it doesn't work at all. See if I can change this to what's the problem again? Launch options string provided by the project system is invalid. MI debugger. Let's undo that for now. How about this one? No luck. Okay. I gotta ban that. Not that. Why does it go back to GTB? CPP debugger. What are the other options? I don't know. That's not going anywhere. Times width plus y. That makes sense. So why does it? No, actually, that's wrong. That should be the height. It's gonna add it to do fix that tomorrow. I think I got some more time. Stuff from padding. Should be y times height. No. Actually, why am I even doing that? No, that's wrong. Probably why. I think this should be the height though. No, this shouldn't. It makes sense to me. That should print. Why does it only print the top? Yep. Jeez, that's a lot. Maybe. Um. $480 minus 32 is 438. No, 48. I mean, it does look more or less right. Alright, you know what? I'm not getting anywhere. Fix printing to memory. Totally wrong at the moment. That's a problem for tomorrow. I have a feeling I'm gonna be stuck on this for a few days, because after that I've got to print the sound wave so I can compare it to what actually plays. Anywho, problem for later. I think that's all for today. Gotta get to the gym and then do work. So thank you for hanging out. That was quite disappointing. Didn't get anywhere. But it's okay. I think we'll figure it out. I think I'm doing something silly. Or something's not right somewhere. Which is good, because once I fix this, I can fix my renderer as well. Because I don't think this is correct. Anyway, we'll figure it out tomorrow. Don't need that. Alright. I guess that's it. Hope you have a good day. And I'll see you back here Sunday. Probably not tomorrow. Alright.